This video is some integer review from your basic skills review package, in case you're having a little bit of trouble with it. So to do integers without a calculator, we want to try to use our heads to do this. We're going to do a couple of questions, and some of them involve exponents. So here we have 6 take away 4 plus 7 plus 8 minus 10. So integer skills are really important when we're dealing with algebra and you have to collect like terms. It's good to be able to add them and subtract them without having to always use your calculator. So what I like to do when I'm adding and subtracting is I like to put all the positives together and then all the negatives together and then look at the difference between them. So I'm going to do the positives first. We've got plus 8, plus 7, and this 6, because it doesn't have anything in front of it, is a positive. So 6 and 7 make 13, plus 8 gives me positive 21. And then for the negatives, I have a minus 4 and a minus 10, which is minus 14 when I put them together. So then what I do is I look at which one is bigger. Well, I have more positives. And then by how much? So 21 minus 14 is 7. So it's a difference here of 7. Do you have to put the plus in front? No, I just did. But the answer here is going to be positive 7. Now, if I take a look at this one here, we have multiplication and division. So I have negative 3 times 5 times negative 4 times negative 10 divided by negative 6 times negative 2. So some of the integer things that you need to keep in mind when you're adding and subtracting or when you're multiplying and dividing is if you have the same sign, like 2 positives, you're going to get a positive. If you have 2 negatives, it's also positive. So same sign gives you a positive answer. And if you have 2 things that have opposite signs, like a plus and a minus or a minus and a plus, that's going to give me a minus. So this works when you're multiplying and dividing, or if you have double signs when you're adding and subtracting. So if you had like 4 plus minus 3, right? You have 2 signs in a row. That's when you would use this. So if you have 2 that are the same, right, you get a positive. If they're different, you get a negative. So here I could do them 2 at a time and work my way through and do it that way. Or I could try to do it all at once. If you try to do it all at once, what you do is you count up your negatives. So I have a negative 3, negative 4, negative 10. That's 3 negatives. Okay, it takes 2 signs that are the same to make a positive. So if you have an odd number, like 3 or 5 or 7, your answer is going to be negative. And if you have an even number, because they have to pair off, like 2, 4, 6, 8, you're going to get a positive. So if I try to do the numerator here, I have a negative, a negative, a negative. That's 3 negatives. So that's going to give me an overall negative answer. 3 times 5 is 15, times 4 is 60, times 10 is 600. Now, some of you might have a little trouble doing that in your head, and it's okay to use a calculator, but I just wanted to talk about your signs here. In the bottom, I have negative 6 and negative 2, so that's 2 negatives. They're paired off, which means I am going to get a positive answer in the denominator, and 6 times 2 is 12. So when I go to divide, I have a positive and a negative, right? I only have 1 negative. They don't match, so I will get a negative answer. 12 goes into 60 5 times, and then that extra 0 means I'm going to get negative 50. All right, and then the last part, and this is why it's helpful to know some integer rules, is when I'm doing exponents, there are some other things we have to worry about. So here we have negative 2 times a to the 3b to the 4 times negative 6 a to the 10 b to the 3 divided by negative 3 a b to the 5, all to the power of 2. So the last section, the previous section, was on exponents. So we said that when you're multiplying things with the same base, you add the exponents. When you divide, you subtract. And when you have brackets with an exponent on the outside, that's when you multiply. So I'm going to start by simplifying the numerator. So coefficients, you just multiply together. So negative 2 times negative 6, that's 2 negatives, right? They match, so that's going to make a positive. And then 2 times 6 is 12. Now, a to the 3 and a to the 10, they have the same base. So that's going to be a to the, we add, 3 plus 10 is 13. b to the 4 times b to the 3, they have the same base of b. So I add together 4 and 3 because we're multiplying to get b to the 7. Now, in the denominator, I have that 2, and the rule is that when you have exponent outside of an exponent, you multiply. So we're going to multiply that 2 times 5, but we're also going to multiply the 2 into the exponent on a. Now, since there isn't one showing there, it is actually a secret one that's been hiding. And we're also going to multiply that 2 into the exponent on the negative 3, which is also a 1. So we're going to get negative 3 to the power of 1 times 2 is 2. A to the 1 times 2 is 2. And b to the 5 times 2, which is 10. Now I am just going to simplify negative 3 squared. So negative 3 times negative 3. So I'm just going to copy this down first. Is positive 9, right? Two negatives. Negative times negative makes positive. So that's 9a squared b to the 10. And then what we're going to do is we're going to divide. So 12 divided by 9. Now 12 divided by 9 does not work out nicely. It will give me a decimal, and I would prefer not to have a decimal. So I'm going to leave it as a fraction, but I am going to see if there is something that would divide into 12 and 9. And I know that they're both divisible by 3. So I actually can reduce this by dividing the top and the bottom by 3. So 12 divided by 3 is 4, and 9 divided by 3 is 3. So this is going to be 4 over 3 times a to the a to the 13 divided by a to the 2. We said when we divide, we subtract our exponents. So the base stays the same, and then 13 take away 2 is 11. B to the 7, b to the 10, the base stays the same, and we subtract. So 7 take away 10, is going to be negative 3 this time. Now I could leave my answer like this, but we like to take our negative exponents and write them as a positive one. So a negative exponent makes a fraction. So it has a flipping over action. It's going to take that b and it's going to flip it down into the denominator. Now I already have something in the denominator, and that's the 3. So the a, which has a positive exponent, is going to stay up top with the 4. And that b is going to flip down into the bottom with the 3, and then the exponent is no longer going to be negative. So we end up with 4a to the 11 over 3 times b to the 3. And that's our integer.